You use Git every day. Add, commit, push. But what is it actually doing under the hood? Forget the scary mental model. Git is secretly one of the simplest, most elegant ideas in software. A key value store. Let's open it up. First, the lay of the land. You work across three areas: your working directory, the files you edit, the staging area, also called the index, and the repository itself, the hidden .git folder. Almost everything Git knows lives inside .git. Here's the one idea that unlocks everything. Git is a key value store. You hand it content, and it hands you back a key, and that key is a hash of the content itself. Git takes a piece of content, runs it through a hash function, historically sha1, and the resulting 40-character string becomes the object's name and its address. This has beautiful side effects. Identical content always hashes the same, so it's stored exactly once. Change a single byte, and you get a completely new object. And because the name is the hash, you can't tamper with anything without Git noticing. And the entire system is built from just 4 object types. A blob is the raw contents of a file, no name, just bytes. A tree is a folder, a list of names pointing to blobs and other trees. A commit is a full snapshot, it points to one top-level tree, plus its parent commits. And a tag is just a friendly label on a commit. Snap them together, and a commit becomes a tree of pointers. The commit points to one root tree. That tree points to every file, as blobs, and every subfolder, as more trees. Follow the arrows down, and you can rebuild your entire project exactly as it was at that moment. And notice, each commit is a complete snapshot, not a diff. Git doesn't save the changes between versions, it saves the whole tree, every single time. But hold on, storing the whole project every commit sounds insane. It isn't, because of content addressing. An unchanged file has the same hash as before, so it points to the exact same blob, nothing is copied, only the files you actually changed create new objects. And later, Git packs everything and delta compresses it on disk. Snapshots in theory, efficient in practice. Picture a project with 70-odd files, you fix a typo in just one of them. Git writes exactly one new blob, a couple of new trees on the path to it, and one commit. Every other file, every untouched object, is reused by reference. That is the whole magic of addressing content by its hash. So what is history? Just commits, each pointing back to its parent. A chain stretching all the way to the very first commit. That chain is the graph Git walks when you run git log. Newer commits know their parents. The past stays immutable. And a branch? It's almost a letdown how simple it is. A branch is a tiny file that contains one 40-character commit hash. That's the whole thing. Main is a 40-byte pointer. When you commit, Git writes the new objects, then simply slides that pointer forward to the new commit. Head is another pointer that tracks which branch you're on. That's why branching in Git is instant and basically free. You're not copying a project, you're creating a 40-byte file. Let's tie it together. You edit files in your working directory. Git add hashes them into blobs and records them in the staging area. Git commit then builds the trees, writes a commit object pointing to them and to the previous commit, and moves your branch forward. Add, commit, that's the entire dance. A few honest caveats. People say Git never deletes, true, until garbage collection finally prunes the objects that nothing points to. Force pushing and rebasing don't edit commits. They create new ones and orphan the old, which is exactly why the reflog can save you. SHA1 is slowly being replaced by SHA256 for collision safety. And because every version of a file is stored whole, giant binaries bloat your repo. That's what Git LFS is for. So here's all of Git in one breath. It's a key value store, where the key is the hash of the content. Files are blobs, folders are trees, snapshots are commits. It stores whole snapshots, deduplicated by hash, and branches are just pointers. Once you can see the hash map, Git stops being magic. That's Git, all the way down, a content-addressed key value store with a few pointers on top. Next time it does something confusing, just picture the objects and the arrows. If this made it finally click, Follow for more deep dives like this one.